Hello, everyone, and welcome back to lecture 13 now. Wow, time's flying by really fast. We've got about another month or so to go, but I think we're there. We're making good progress. So in this lecture, I want to cover about function overloading, and then function with default arguments and inline functions. So they're all about functions, and depending on where we are at the end, I might go a step beyond and start talking about classes. But let's see if we make it that far. Okay, function overloading, what is it? It's a process where you have the same function name but different types of parameters or different number of parameters. Um, when you think of the word overload really means you're putting in too much, right? Too much into the function, but I don't think there's such a thing as putting too much into the function. I mean, the most I've ever seen is, honestly, I haven't even seen 10 parameters to the function. That's the most. I think maybe 5 to 7 is what I've seen, and 5 or below is what most people tend to use. You can use it if you have some specific need, but generally speaking, you don't see that many parameters to the function. Now, when I was trying to come up with a way to explain this to you guys, I kept thinking of the word overload, right? But I don't know why such a terminology is used for C++ in the programming languages because you're not really. Okay, so yeah, for overloading, you're not overloading the function, right? You're just adding more parameters to it. Um, But I guess in one way, overloading might make sense because you're adding more number to the existing number of parameters. So there is sort of that correlation. But anyways, it wasn't obvious to me. But nonetheless, let's keep moving forward. So the way you go about overloading a function is you change the number of parameters. So if you've got an addition, a function that does addition, it takes in two arguments. You can overload it to take in three arguments or four or five or whatever. That's one way of overloading. The other one is you change the type of parameters. So let's continue on with the same example of the addition function. So it takes in two integers. Well, you can change it to take in two floats or one float or two integers, two float, and something else after that. It's really up to you. So those are the two ways. Now, one thing you won't really see and isn't really all that common, although in the example you'll see is, you'll in the example you'll see the return time is changed, but typically the return type is the same. In most of the functions that I've seen, the return type is the same, but the number or the type of parameters is changing. So let's focus on those two areas, and then we'll go from there. Okay, so hopefully the concept of function overloading is clear. Next up is, well, that's overloading, right? What are we going to gain out of overloading? Um, you can use one method name for conceptually same type of operations. So I was talking about a method that's a addition that does addition, but you're overloading that. Now, to the end user, it's quite obvious because the name of the method is still the same, but the parameter parameters are changing. So in his mind, conceptually, it is doing the same thing. And it also gives him the flexibility to pass in different type of parameters, number of parameters, and the other 3 points, right? Well, there's a typo here. It should say helps in debugging special scenarios, code reusability, readability, and reuse. Now, if you recall to our previous lecture, when I first introduced functions, I said, look, by using function, you make the code very much readable. And one of the exams in the midterm, or one of the question in the midterm was, can you get away without writing a function, right? Can you just write code or everything in one file? Well, theoretically, yes, you can have everything in the main function. However, understanding it, reading it, debugging it is going to get very cumbersome. Imagine you wrote a piece of code in a company and then 10 years later someone and over the and every year, every few months or so, people keep adding code to it. Imagine 10 years down the line You had a main method that does bunch of stuff, which was 100 lines. Well, in 10 years, it might have grown to 10,000, 5,000, whatever that number is. And the person coming at the 11th year trying to debug it and understanding, he's going to be scratching his head. He's going to be like, oh my God, what is this? So breaking your code up into smaller chunks, into functions, and eventually headers and CPP files and things like that makes code very readable, makes it reusable. Other drivers can use the same functions that's been implemented, and maintenance of that code is is also very easy. And I've seen it from practical examples. And what I'm talking about right now, right? This file kept growing over the span of 10 years. At the end of it, it's a headache. As opposed to every time you needed to add some functionality, you add another function and and that function is used could be used across multiple drivers. Now it turns out if the issue is in that function, your the the bug, the issue is isolated to that function itself. You go ahead in it, change it, test it, and release it out the door. Um, so it has these are just some of the benefits that I mentioned for function overloading and function usage, but I mean it's really a lot though. And even overloaded functions, people can use them again and again. No harm there. Um, and if anyone is working out in the field and or programming even a little bit, this concept is going to be quite obvious to you, right? Let's say if you've taken Java and this is a secondary language you're taking, although most people, this is their first degree, so you might not have exposure to the other languages, but nonetheless, let's say if you've taken other languages, this concept is like second nature to you. Okay? What I'm going to do right now is I'll cover a couple of examples related to function overloading. Let me close that. I was looking at what's going on with Netflix, but that's besides the point. That's outside this class. Okay, so in this function, I have in this file, I have the main driver. Okay, it's gonna call absolute value of -5. It's going to call the function absolute. The name of the function is absolute, but there are two types of absolute. One absolute takes in just one float and returns a floating number. The other one takes in an integer and then returns an integer. Okay, so here I say absolute value of -5 is, I'm calling this method right here. This, now if you, if, since this is an integer, what the compiler does and the way the compiler goes about executing this, it says, okay, the name of the method is absolute. It starts from top down, and it looks like it's taking an argument of -5, which is an integer, and this one takes in a float. It's like, no, no, no. Okay, then it goes to the next one. Okay, it's absolute. It takes in an integer. Ah, it's got to be this. So the way the compiler goes about it is from top to bottom, whichever method is first, it looks at it and it compares the signature. And in this case, it looked at the signature and found out it's an integer, returns an integer. Well, the return type was irrelevant for the compiler. It looked at the name and the argument that it's taking in, and that's how it decided it's this one. So let me just go ahead and run it. Absolute value of -5 is 5 because that's what the method is doing. If it's less than 0, var equals to -var, and then you return the variable. Okay, so it takes off the negative out of there in case if it's a negative value. Um, and now the next one is call function with float type parameter. So it absolute value of 5.5, you call absolute with a float. So the compiler starts from the top. It says, okay, I know absolute float. Ah, here we go. This is the method it ought to be, and it executes it. Okay. So that's how we go about overloading a method, and that's how the compiler goes about figuring out which is the right implementation that it should be going towards. Name is the same, but the parameter type is different. The number of parameters in this one was the same, but the type was different, and so was the return type. Right, let's move on to the second example. In my second example, I have three different display method. Okay, one display, uh, so a display method that's overloaded uh, X number of times. Now in here, you notice that the return type is the same, but the number changes and the type also changes. In the first one, it takes in an integer and a double, and then it says this is an int and this is the double. The second one, excuse me, which is a display, it takes in a double and it says this is double. Okay, it just outputs that value. And then the third one, it takes in an integer and it says this is the integer number. And in the main function, what I do is I declare an integer and a double, and then I call the first one display A, display B, display AB. Now, let's think about this. The first display is with an integer. So the compiler is going to go top down. It's looking for the method name display and then and a parameter to display as an integer. Well, it comes here, it's like, oh, you know what though? It's it takes in two integers. I mean, an int and double. No, it's not that. This one takes in a double. It's not that either. Then it comes down here. It's like, oh, this one's taking integer. It's gotta be it. So then the first output ought to be integer number A, which is 5. Okay? Next one calls display B. B is a double. Starts from the very top. Double, int, double. No. Display takes in a double. Yep. Then it should say double number. So far, first it's going to say integer number for this one, and then it's going to say double number. Then, now you're going to call it with two parameters, an int first and followed by a double. And that should be obvious by now. It's this one right here. So we just go ahead and run it. First one was integer number, second one was double number. The third one was integer number is this, and that's a double number. Okay, now watch what happens. Let's say, for example, mm, let's make this obvious. What if I said AA? What's the compiler going to do? It's going to look for a display method that takes in two integers and it's not going to find it. Guess what's going to happen? You might be thinking it's not going to work, it's going to throw a compilation error. But what it did was, um, look at the previous one, A and B. Double was that. But what did it do here? Right? It took in both those numbers. So it thought the other A as a float. We kind of made it in the float in the background. Um, and then still called this method right here. So it's not going to result in a compilation error. Now, if you really wanted to be explicit about it, you could have static cast this guy to a double, so your double number ends up being 5.0. But I don't really go into all the details. I just wanted to clear the misconception that if you if you do something like this and you might expect a compilation error, no. Compiler is smart enough. It kind of deals with the integer as a double and still calls this method. Doesn't exactly deal with it as a double, but it nonetheless calls that method. So it's not going to result in a compilation error. Hint, hint. This is something I might ask in the final exam, right? I get an idea. Okay. Anyway, so that's for function overloading. Okay, so now continuing on with the functions with default arguments. Now this is yet another cool feature of functions. You can do so much, right? I mean, this is yet another foundational block of programming, but we're seeing so much. We're figuring out how to write a function, separate those functions into header implementation files, overload those functions. Now, functions with default arguments. The way you go about doing this is you can have a function that takes in different parameters, but some of those parameters you can give it default values, okay? And the way you go about doing that is the function name, or the return type, function name, the type, the parameter name, type, oops, the type of parameter name equal to something, okay? Uh, just for the sake of simplicity, I've shown two parameters, and one of them is defaulted to something. So, for example, if it's an int number, you'll default it to 0. Um, and some things to keep in mind when it comes to these default arguments is the default type is on the function prototype and not its implementation. So, for example, if you've got a header file and an implementation file, in the header file is where you will have this default mentioned, not in the implementation file. Or if you have the prototype, the signature of the function up at the top of the driver file or the main function, up at the very top you'll have the defaults there, but lower down in your underneath the main method, if you have the implementation, in the implementation you will not have the default mention. It's illegal, it's not allowed. And you'll see an example of this. And the arguments with default should be towards the end of the argument list. So if what you should not do is have the first parameter default to something and the second one not default to something, but flip it around. The first parameter should be non-default, the second one should be default. Or if you've got 3, 4, or 5, on the right side, the 3, 4, and 5, those parameters ought to be defaulted if you want them to be, and not the first and second. That's just a good, it's just a great practice and continue to do so. I think it's not even going to allow you if you have the first one. Yeah, if you have the first one to be defaulted. Okay, it's towards the end. And then caller may decide to leave the values out so as to use the default value. So when a caller is calling this method, he can only give it the non-default values. So in this particular example, he'll call the function name and he can decide only to give one parameter. The second one is defaulted, he can just skip it. And you'll see the uses of this. It's got tremendous uses. Couple other points for default arguments. We learned about the call by value and call by reference. Now, non-constant reference parameters are not defaulted. Typically, we don't do that because, they're not constant. They can change, right? So you want to give user the ability to do so. Whereas the const reference parameters may be given a default value. Let's say, for example, you have a function that takes in a string and that string is an input from the user. Well, let's say, for example, the user never did input anything. So it's a good practice to have that string reference be defaulted to an empty string. Okay, so this is about functions with default arguments. Let's go ahead and look at an example here. Um, okay, so in this example, this is the prototype, the signature, and this is the implementation down here. In this method, I say int sum. It's a summation method. It takes in x, y, z, and w. Now, x and y do not have a default value, whereas z and w have a default value. Now, keep in mind, this is the signature, and down here is the implementation. Down here, I've not mentioned the default at all. You should not do that. So keep that in mind. And then I return x, y, z, and w. The user can decide to skip these two parameters or not. He can give values for it, or he can not give values for it. It's up to him because if he gives the value, you'll see what happens. If he does not give the value, see what happens. Now, in this case, the first time, see out sum 10 and 15. X and Y is 10 and Y is 15. So we add 10 plus, oh, I'll run it right here. I should have not shown you the output because it's going to kind of mislead you. So look at this. Anyways, now that you've seen it, 10 plus 15, this is defaulted to 0, this is defaulted to 0. 25. So you're able to call it with just two arguments. Remember we said in the slide, the user can decide to skip or not give the two extra arguments. Um, okay, second case right here. He gave it a value. So in case when the value is provided, use the you do not use a default value, but use the value provided by the user. So using a default is just kind of like a fallback mechanism that if the user doesn't provide the value, you have it defaulted to something. So 10, 15, and 25, and then W is going to be defaulted to 0. You add 10 plus 15 plus 25, you have 50 right here. Okay, now this third statement. The user has decided not to use any of the default values. 10, 15, 25, 30. You add all of those up, you get the number 80. Okay? So that's how you go about using or working with default functions with default values. Now let me show you guys another example. In this one, there's a display method right here, and both of the two parameters they have a default value. Display takes in a character and it takes an integer, and in this case, the default is an asterisk right here, and then the integer 3 right here. And in the main function, I have and watch here. Once again, the default is up here, but not in the implementation down here. So int count equals to 5. Um, Before I go ahead, let me show you this. Uh, let's say, for example, you had this, right? I comment this out. So what I've done here is, one of the things that I mentioned is you should not have the beginning or the earlier or the first parameter as defaulted, and then the second one non-default. Let's see, watch what happens. I think it was right there. Yeah. Note following parameter one, which has a default value. So there's a compilation error, so you cannot do that. So Control Z. Okay, that was just to illustrate that point. So int count equal to 5, no argument passed. Calling the display method, giving it no argument. Then in that case, the default asterisk and 3 as are going to get used. First argument passed. I'm calling display with just one character. Then the pound and the number 3 is going to be passed 3 because that's the default. And here I'm giving it both parameters. So it's not going to use the default value, it's just going to use what the user provided. In this case, it's the dollar sign and the count. Count is 5. Let's go ahead and run it. No compilation error. No argument passed. So what it did was, oh, and the way the display method works is I loop from I equal to 1 till the count, whatever the user passed in, and then I keep outputting that same character. So in the first case, the count was 3, and the character that was sent in was the asterisk. So it outputted asterisk 3 times. Second time, it's pound and 3. So it goes through the loop and it outputs pound 3 times. Third time, the character is a dollar sign and the count is number 5. So we see the dollar sign 5 times. Okay, so those two are the main examples that I wanted to use for explaining to you or going over the methods with default functions. As I always say, try it out, play around with it, and you'll be much more comfortable. And as you're playing around with it, you'll start seeing the uses of this more and more. And if you have any questions, feel free to email me, text me. If you want to set up some time, we can go over it. Uh, we can go over it in a Zoom or Microsoft Teams meeting or whatever, so we can even do screen sharing. Um, since the class is online, but I'd love to get some feedback from you as well. Um, okay.
Okay, continuing on. The next topic is inline function. Inline functions is a very powerful tool in C++ that's used a fair amount of time. Now, we learned about functions, we learned about overloading functions. Leave everything as it is for a function, and word, if you put the keyword in this keyword called inline right in front of the function, it's called an inline function. And typically what happens is, uh, the compiler, when it scans through the code, anytime you call a function, it will paste the content of that function right then and there. So your main file where you're calling these functions gets much larger. Now you might be mentioning, well, that's going to increase the byte size. So this is where things kind of come into play for an inline function. So typically, the way functions work is if you call a function, the compiler switches from one memory location to the other. The function is stored someplace else, so it goes and gives the control over to that piece, executes, and then comes back to the main function if that's the one that's calling the function, right? So you do all this back and forth. Well, it's good because let's say, for example, you're doing some complicated computation in there. And that complicated computation takes a while. And anytime you switch or the program and the compiler gives control to some other function, there is a a downtime associated with it, right? So you're going back and forth from the main function to the function that's called. But if there's large computation, this time that's spent in calling the function back and forth becomes negligible. Now, if in case where the computation is small, what'll happen is you end up spending more time in switching context from one place to another. In situations like this, you might as well have an inline function. So the rule of thumb is if it's a few line, one inline, if it's one line, let's say, worth of a one or two lines worth of a function, you can then go ahead and have it in an inline. No big deal. You can, and then uh, that's gonna help things because, yeah, let's say a function that occurs in one line, it's gonna happen fairly quickly. The compiler's gonna waste all this time. Why not just paste the function right there and go on with your life? Okay, so that's what an inline function is. But one thing to keep in mind about inline function, the compiler may not perform inline functions in these following circumstances. If a function contains a loop, compiler is smart enough. I mean, it's one of the things to keep in mind is it's you can't really command the compiler to say no, you have to use this inline function. There's some places where it can choose. If you get a loop, in that case, it knows that there's fair amount of computation going on, so it's not going to go ahead and execute the inline function. It's going to treat it as a regular function. If the function contains a static variable, it's not going to be inline. If the function is recursive, I know we haven't covered recursive function, but just know this, that if a function is recursive, compiler is not going to honor or make it inline. If the function is return type is other than void, then return statement doesn't exist in the function body. If a function contains switch or goto, compiler says nope, can't do. Okay, so these are such some of the situations um, for which the compiler doesn't do inlining. Now that I come to think of it, I think this is good quiz material. Okay, anyways, moving on. The advantages of hold on, let me just show you an example of the inline function. So here you go. Oops, close this. Um, and this method let me show. So in this one, there's an inline function called max, right? So without the inline keyword as it's just a regular method right here, x greater than y. If that is the case, return x. If not, return y. Simple as that. So here you have cout max of 20, 10. Which one's max? 0 or 200, 100 or 110. So essentially what the compiler does is it sees this statement, it's going to copy all of this right here, right? So the size of the file gets bigger. I think we talked about it, right? It depends. In this case, it's a one-line statement right here. Why switch context back and forth? Just execute it right then and there. So let me just go ahead and run this program. Max of 20 and 10, 20. 0 and 200, it's 200. 100 and 1010, it is 1010. It's as simple as that, right? Okay. I did mention some of the good things in the context switching, this, etc. But these are some more of the advantages of inline functions. So the function call overhead doesn't occur. It saves overhead of push pop variables on the stack when the function is called. It saves the overhead of returning from a function. So the calling of the function, returning of the function, both of those times are saved. When you inline a function, you may enable the compiler to perform context-specific optimization. Right? We kind of mentioned this earlier where, the switching of context can be time consuming and its function is simple, it's one line, it's small, it can be done quickly, and you're going to be calling it again and again. Maybe um, you don't need a function call for that. Inline would be sufficient. Inline function may be useful for embedded systems because inline can yield less code than the function call, right? Um, one thing you might be thinking of is if the compiler is going to paste the code right then and there, why bother writing the function? Well, one thing you do avoid is pasting that function yourself over and over and over again because where you might make a mistake, but you've declared it to be a function. You put a keyword in there and it's out there. Yeah, you have to copy paste it all the time. You just name the function and it gets called, right? The other thing is in future at some point you decide to change the function, put more logic in it, make it more complicated, and at that point it's not making sense for you to have it inline. You can just remove the keyword instead of changing it in all these other places. Okay, so the disadvantages, it does have some, because I've been kind of praising the inline function, how great it is. But if you use too many inline functions, then the size of the executable file will be large because duplication of the same code, right? That goes without saying because if you've got pasted similar code all over and over again, duplicate code, size of binary executable is bigger. Why do you care? Well, if you're moving it from one place to another, and you've got some server size limitations on the server, that's some of the examples that you might run into, or issues you might run into with the large executable. Um, the inline function, it also might increase the compilation time. So, for example, if someone's trying to compile and you've got tons of inline function and you keep adding more to it and you keep adding more to it, um, then you might hit a point where the compilation time is significant enough because in software development we want to make the change, compile it, and try to test it as quickly as possible. But I mean, even if your compilation time is in minutes, it feels like you're twiddling your thumb and nothing ever is happening. Waiting seems like eternity. Um, but like I said, it's a judgment call, right? You decide when you want inline versus not inline. These are general guidelines. I hope it's clear. So that's all for today. Have a good day.